In this video, I'm going to talk through the Unit 1 Assessment multiple choice questions. I'll put a link in the description of the video to the times that I'll do each different question, so that if you only got a certain one wrong, you can just look at that one straight away. Okay, so let's get started. Question 1. During the first 20 seconds of a chemical reaction, 5 centimetres cubed of gas were given off. The average rate of reaction in centimetres cubed per second during the first 20 seconds is. Okay, so I've got a time of 20 seconds and I've got a volume of gas 5 centimetres cubed, and it's asking me about the average rate of reaction. So you might remember this, or you might need to have a quick look in your data book to remind you. The rate, or the average rate, is given by the change in quantity divided by the change in time. So the quantity here is 5 centimetres cubed of gas given off. So I might do a little bit of working if I was doing this myself in a test. So rate is change in quantity divided by change in time. The quantity is 5 centimetres cubed. The time in this case was 20 seconds. 5 divided by 20. If I do this in my calculator, that gives me 0.25. Now I don't need to worry in this case about the units, but I can check. So my quantity was centimetres cubed, my time was 20 seconds, so that will give me units of centimetres cubed per second. So the correct answer for 1 is D. Question 2. An atom has 13 protons, 13 electrons and 14 neutrons. And the atom has, therefore, it's giving you different options for atomic number and mass number. Now, this is a question where you really just have to know the definition of atomic number and mass number. If you didn't get this right, you need to go back and you need to revise these, and you need to learn these definitions. So the atomic number of an element is the number of protons. So if the atom has 13 protons, it must have atomic number 13. Just by knowing that, we actually can eliminate B, C and D, but just to check, so the mass number is the number of protons plus the number of neutrons. 13 plus 14 equals 27, so that again confirms that A is the correct answer. Okay, question 3. What is the charge on the iron ion in iron chromate? So you've got FeCrO4. Now, this is a slightly more difficult type of multiple choice question, I would say, but we did have a look at those in class. Clue, if it ends in 8, or if it's one of these group ions, ends in 8, hydroxide or ammonium, then you're going to find information about that ion on page 8 of the data booklet. So if we go to page 8, what we can see here is that the chromate ion is CrO4 2-. Now the charge of that chromate ion is going to help us to figure out the charge on the iron ion. So chromate is CrO4 2-. And in the formula is FeCrO4. So that tells us that there is only one iron ion for every one chromate ion. Now in an ionic compound, the charges have to balance out. So if there's only one iron ion for every one chromate ion, the charge of each iron ion must be 2+, for that to balance out the charge of the chromate ion, which is 2-. So the answer for 3 is B. Okay. Question 4. Which of the following elements forms an ion with a single negative charge and an electron arrangement of 288? Okay, so first of all we have to think, what type of ions, or what type of elements might form negatively charged ions? Well, negatively charged ions are formed by non-metal elements. So actually straight away we can rule out sodium and we can rule out calcium. If you've got a good memory, you might also think, well, argon is a noble gas. I know that noble gases are unreactive. But you can also double check and think about the electron arrangement that the element would form. So if you are asked about electron arrangement, you can find information about that on page 6 of your data book. it says an ion with a single negative charge and an electron arrangement of 288. So that's the ion it's talking about. So argon already has an electron arrangement of 288, but that is not the electron arrangement of a negatively charged ion. That's the electron arrangement of an argon atom. So the elements that would form ions with a single negative charge are group 7 because they need to gain one more electron to get a full outer shell. Based on that, if chlorine was to get one more electron, then it would have an electron arrangement of 288. So when we look back to question 4, the answer is B, chlorine. But you should be able to work that out just on this negative charge clue in the question. That's really important. Okay, question 5. Question 5 should be nice and simple as long as you can remember how to balance equations. So it says XAl solid plus Y Br2 liquid makes Z AlBr3 solid. We don't really need to worry about the state symbols here, but what we're trying to figure out is what numbers do we have to put in front of each of these symbols to balance this equation, and what therefore will X, Y and Z be. So if I was doing this again, I would actually rewrite this to just help myself out with my working. Always better when you're doing multiple choice questions to write as much as you can to help keep your thinking clear, and that means that as well when you come back to look at it, you'll be able to understand what you had done to work out the answer. So to balance this equation, I'm going to count the number of each type of atom on each side. So I've got 1 aluminium on each side, 2 Brs on the left, 3 bromines on the right. So I've got aluminiums are balanced at the moment, but bromines aren't. Now I've got 2 and 3. That's going to be a little bit more difficult to balance, but I can do that by making them both up to 6. So if I have a 3 in front of Br2, that gives me 6 bromines on the left. And if I add a 2 in front of this one, 2 times 3 will give me 6 bromines on this side as well. Now I've also changed the number of aluminiums on the right, so I'm going to recount those. And then in order to make the aluminiums balance as well, I need to add a 2 in front of my aluminium. So if you were struggling with that question, you need to do more practice of balancing equations. I would recommend Miss Adams' video on that, and I'll put a link to it. Okay, so the answer for that, we've got 2, 3, 2, 2, 3, 2. B is the correct answer. Okay. Question 6 should again be a fairly easy one. If you didn't get 6, it's because you've not done enough revision. An acidic solution contains, I could forgive you if you'd guessed only hydrogen ions. H+ ions, hydrogen ions are associated with acids, but acids don't contain only hydrogen ions. Acids contain more hydrogen ions than hydroxide ions. So if you weren't getting that, you need to make sure you go back through the acids and bases topic. You might want to look at BBC Bite Size. Okay, question 7. Which of the following compounds is a base? Again, if you didn't get this one, you just have not done enough revision, or you maybe made a silly mistake. So bases, you should know from your acids and bases topic. Bases are metal oxides, metal hydroxides, and metal carbonates. So when we're asked what is a base, we're looking for a compound which has a metal at the start of the name and then ends in either oxide, hydroxide or carbonate. The only one in question 7 which fits that bill is D, potassium carbonate. Okay, question 8. We've got an equation here, so we've got H+ hydrogen ions AQ in solution, so hydrogen ions in solution plus NO3-, that's nitrate ions in solution, plus potassium ions in solution, plus hydroxide ions in solution. So we're mixing together solutions containing different ions, and we are then our products of our reaction again, we've got ions in solution and we've got water. Now, from the H plus and the OH minus ion, straight away I can actually think this is probably a neutralization reaction because we're forming water. And it's asking, what are the spectator ions? So remember, the spectator ions are ions that are in solution and the same charge on both the reactant side and the product side of the equation. So you're looking for ions that are AQ and the same on both sides. So here we've got our NO3 minus and our K plus are both present on the reactant side and in the product side. They're AQ, they're in solution on both sides. That means that nothing has actually happened to these ions. They've just viewed the reaction, if you like. They're spectator ions. So the answer for this one is NO3 minus and K plus. So it's not that one. NO3 minus, no. So it must be D. Okay, right, question 9. Question 9 is a little bit more difficult. So question 9 says 0.2 moles MOL of a gas has a mass of 12.8 grams. And it's saying which of the following could be the molecular formula for the gas. Now, when you're given information like this in a question, first thing you need to think about is, what is this information telling me? So 0.2 moles, that's the number of moles, that's N, and the mass of 12.8 grams, well, it actually even says mass in this question, so that's our mass. Now, you might not be that sure about where to go from there, but what you can do if you're given a question and it's got some numbers, you think it might be a calculation, just have a look at your list of equations in the contents page and see if there's any that you might be able to use. So we've got N number of moles in this question, so that makes me think we're probably going to need to use one of these two equations. It doesn't talk about concentration or volume, but it does give us a mass. So I'm thinking at the moment we're going to need to use N equals M over GFM. So I'm going to write that down, N equals M over GFM. That might be something to do with the answer to this. And actually, looking at this question, which of the following could be the molecular formula for a gas? Well, if I can work out the GFM from the number of moles and the mass, then I can compare that with the GFM of my different gases, and I can figure out what the GFM of the gas, what the molecular formula must be for a gas where 0.2 moles weighs 12.8 grams. So N equals M over GFM, you can put that into a little triangle if you want. Remember, mass is on top in here, so mass must go on top in the triangle. So GFM is then going to be M divided by N. Okay, so 12.8 was the mass. The number of moles was 0.2. Do that in my calculator. 12.8 divided by 0.2 equals 64. And that is grams per mole. So we're looking for a compound where 1 mole of the compound is 64 grams. In other words, the GFM is 64. So we're going to have to, in this one, calculate the GFM of all 4 of these compounds to see which one it is now. Let's get the right page of the data book. Okay, so let's start at the top. Sulfur dioxide, SO2. Sulfur dioxide, SO2. So oxygen is 16, so we've got 2 times 16, and then we've got sulfur is 32. So we've got 2 times 16, 1 times 32, 2 times 16 is 32, 1 times 32 is 32, 32 and 32 is 64. So actually, without even doing any of the others, my GFM was supposed to be 64. First one, sulfur dioxide, SO2, has worked out as 64. I'm not going to bother to calculate the rest of them because in the exam that would be a waste of time. I'm pretty convinced that A is the right answer. If I have time at the end, I might go back and check the others. Okay, question 10 then, finally. Which of the following solutions contains the least number of moles of solute? So you've got lots of different numbers here, and you're asked for the least number of moles of solute. Now, again, you see moles, you should think N in these equations that we know. Okay, and this time we're given some different information. We're given centimetres cubed, so that's not a mass, that is a volume. Okay, so you should know that centimetres cubed is a measure of volume. And then we're given 0.4 moles per litre solution. So moles per litre, you should know, is concentration. If you see moles per litre, MOL, L to the power of -1, you should know that that's a concentration. So what we're going to be using in the this question, we were asked about number of moles. We've got concentrations and volumes, so we're going to be using N equals CV. Okay, so N equals CV. So we're just going to do C times V for all of these numbers, and then we're going to figure out how many moles each of them is. Now, one thing we've got to remember is that V is in litres. So to get from centimetres cubed to litres, you're going to divide by 1,000. So the way I would do this is that I would do this quickly in my calculator if I was doing this in a test. So we're going to do C times V. The V we have to divide by 1,000, so I'm going to do 100 divided by 1,000, and then I'm just going to times it by the concentration. So I'm going to get 0.04 moles on that first one. And then I'm just going to repeat the process. So I'm going to do the volume divided by 1,000, and then times by the concentration, 0.3. So that's 0.06. Okay, and then I'm going to do the volume divided by 1,000, and then times by the concentration, which in this case is 1. So that's going to give me 0.3. And then I'm going to do again the volume divided by 1,000 to give it to me in litres, and then times by the concentration, which is 0.5. Okay, so that's 0.2. So each case, I've just done C times V, concentration times volume, and I'm looking for the least number of moles, which is the smallest number, which in this case is A, 0.04 moles.